Audio testing. Yes. Okay, it's working. If anyone's here and has any math questions, feel free to scan the QR code and submit your question, and I'm happy to take a look at it and help. Also, if you have a question, I can see chat. So if you have any questions, please feel free to ask. Hello. How are you? If you have any questions you want to do, you could scan the QR code, or you could just type the question in if you want. But if you want help with anything, scan the QR code, fill out the form, and then that way I can see the question. But yeah. How are you doing? I'm just glad work is over today. Think you're ready for the test tomorrow? Can I do the cotangent of theta over 1 plus cosecant theta multiplied by that? Oh, okay, yeah, sure. Give me 1 sec to write that problem. Let's see, it was, I'm a little rusty with this, so give me a little leeway with that, okay? That was cotangent. All right, you have to click there. Why is that not working? There we go. Okay. We got cotangent of theta divided by, what was it? 1 minus cosecant theta. And it said we're going to multiply them by, well, cotangent theta times over 1 plus cosecant theta. And we're going to multiply it by 1 minus cosecant theta over 1 minus cosecant theta. Okay, so for this problem here, we're going to multiply the top and the bottom. So the cotangent theta and the 1 plus cosecant theta. We're going to multiply those by 1 minus cosecant theta over 1 minus cosecant theta. For the numerator, I'm just going to leave it alone. I'm just going to leave it as cotangent theta, so cotangent theta times 1 minus cosecant theta. So for my numerator, I'm just going to leave it like this. The denominator is where it gets more interesting. So to multiply this out, we need to FOIL it. So we're going to do 1 times 1, which is 1. We're going to do 1 times negative cosecant theta, which is negative cosecant theta. We're going to do cosecant theta times 1, which is a positive cosecant theta. And last but not least, we're going to do cosecant theta times negative cosecant theta, which is a minus cosecant theta squared, or minus cosecant squared theta. The nice thing about this is these two middle terms here of minus cosecant theta and positive cosecant theta, they just reduce. So if we simplify that, we're down to just cotangent theta times 1 minus cosecant theta in the numerator. And our denominator has become just 1 minus cosecant squared theta. So with this problem here, we're going to be using the 1 minus cosecant squared. We need to substitute that. And if I remember correctly from notes, I want to say we had a Pythagorean identity that said something like, I'm trying to think it through before I say it. Yeah, I think it was cotangent squared theta. What was it? Where you divide everything by sines? Let me double check this one before I say it. It's been a long day. Pythagorean identity. We have 1 plus tangent squared equals cosecant squared. So yeah, we have 1 plus cotangent squared equals cosecant squared. That's a really bad even 1 over there. So I need to somehow get this 1 minus cosecant squared theta to show up over here. I'm going to do that by subtracting the cosecant squared theta to the other side. And I'm also going to subtract the cotangent to the other side because I don't want that over here. So this left side will just turn into 1 minus cosecant squared theta. And this right side will just turn into negative cotangent squared theta. I know there's a lot of writing there, but I'm hoping that makes sense. I move the cosecant squared to the other side, which is why it's a negative cosecant squared. I also move the cotangent squared to the other side, which is why it's a negative cotangent squared. But the idea I'm trying to get across is that we can replace all of this denominator with negative cotangent squared theta. Because we know negative cotangent squared theta is 1 minus cosecant squared theta. So we have cotangent theta times 1 minus cosecant theta over negative cotangent squared theta. And last but not least, the cotangent in the numerator and the cotangents, the square of the cotangent in the denominator reduce. And we are just left with 1 minus cosecant theta over negative cotangent theta. And that's the final answer right here. It might look weird with a negative in the denominator, but it's okay if you leave it in the denominator or if you move it up to the numerator. Either way is fine. Where did the square go? So here I can explain that. So I think you're talking about in this step over here, right? So let me back up a little bit. Okay, good, you can hear me. Okay, awesome. So in the step before this, remember in the denominator, that square, all that means is we're doing cotangent times cotangent. It just means you're multiplying a cotangent by another cotangent. So what I'm doing in this step here is, so in my numerator I have cotangent theta times 1 minus cosecant theta. What's going on in the denominator is we have a minus sign still down there. This cotangent squared theta just means we have cotangent theta times another cotangent theta, right? That's what it means to square something, is you multiply it by itself. That's what cotangent times cotangent is, cotangent squared. And so I'm eliminating one of those cotangents from the bottom. I'm eliminating this with one of those. So when I do this, I eliminate with that with the 2 there. So the square goes away when you do this. When you eliminate the cotangent here with the square there, it makes it so you just have one cotangent left in the bottom, which is what we have. Yeah, and so then after that, yeah, it just simplifies down to, like I said, 1 minus cosecant theta over, and now a negative cotangent theta. The cotangent would not be squared anymore because we got rid of the square with the one on the top. Just because you're the only one typing, is the audio okay? Is there anything you think I should do better with this? Like, what do you think? That's good. Cool. Yeah, if you have any questions, feel free to just scan the QR code to submit them or to just try and type them in chat. I can try and figure it out. It's I know how hard it is to type math though. So, yeah, if anyone has any other questions. What about sine of pi over 12? Sure. Sine of pi over 12. Where did I go? Okay. Oh, wrong one. Oops. Here we go. Okay, so I can just add a new layer and then get rid of that layer. Okay, cool. So sine of pi over 12, you might have noticed, is not on your unit circle, right? So it might seem like a trick question in that sense, because sine of pi over 12, if you're thinking about, oh, I'll just go to my unit circle. I also had this ready to go. If I go to my unit circle, there's not a pi over 12 on the unit circle. It's nowhere to be found. It would be somewhere like, oops, it would be somewhere here between pi over 6 and 0, but we don't know what that value is. So to do sine of pi over 12, we need to think of pi over 12 as something different. We need to think of it as either a sum or a difference. I would personally do a difference. And I would really like to pick some values that are in quadrant 1, because I really don't want to go outside quadrant 1. And so if I remember that pi over 12 is somewhere here between 0 and pi over 6, I'm kind of thinking I'm going to definitely be subtracting. There's no way if I add pi over 6 to anything, or if I add two of these together, there's no way it's going to give me a value down here. I think I need to subtract to get that. So to make it work, there we go. To make it work, I'm thinking it's going to involve pi over 3. Oops, the current layer is invisible, thus could not be edited. Now will it work? I'm thinking I want to use pi over 3 and pi over 4. Just because they're both in quadrant 1. I could try pi over 6. I just have a feeling it won't work, but it's not that bad. So I'm going to try and subtract these two and see if that equals pi over 12. To add or subtract fractions, we must get a common denominator. So I'm going to multiply this one by 3 and this one here by 4. My numerator will turn into 4 pi over 12 minus my other one here will turn into 3 pi over 12, which means if I subtracted these, I'd be left with just pi over 12. So the idea I'm trying to say is that pi over 12 is the same thing as pi over 3 minus pi over 4. Pi over 3 minus pi over 4 gave me pi over 12. So that means I could think of this problem, instead of sine of pi over 12, I could think of it as sine of pi over 3 minus pi over 4. And sorry, I just realized how small I wrote that. Let me write that a little bigger. So I could write it as sine of pi over 3 minus pi over 4. This is a version of sine of alpha minus beta, which we should have from our identities, right? Sine of alpha minus beta is equal to sine alpha cosine beta minus cosine alpha sine beta. In this case, my alpha is pi over 3, my beta is pi over 4. So this becomes sine pi over 3 times cosine pi over 4 right, where my alpha is pi over 3, my beta is pi over 4, minus cosine pi over 3 times sine pi over 4. And then all of a sudden this becomes just a unit circle question. Sine pi over 3 means what's the y value at pi over 3? So I'm going to go to my unit circle. The y value at pi over 3 is root 3 over 2. So I'm going to replace sine pi over 3 with root 3 over 2. Times cosine pi over 4, the x value at pi over 4, which is root 2 over 2, minus cosine pi over 3, the x value at pi over 3, which is 1/2, times the y value at pi over 4, which is square root of 2 over 2. And from here, I'm just going to multiply. Root 3 times root 2 is root 6, divided by 2 times 2 is 4, minus 1 times root 2 is root 2, 2 times 2 is 4, and then if I want to make this look nice, since they're both being divided by 4, I can write this as the square root of 6 minus the square root of 2, all divided by 4. Would it be okay if you did pi over 2 and pi over 6 and make those common denominators? Possibly. We would just need something that works out to be pi over 12. So you were saying, Princess, if we did pi over 6 and pi over 2, with this, I would want to figure out some way if I add or subtract to these that it gives me pi over 12. So I might try subtracting them first and see what happens. So I would get a common denominator with, wait a minute. Yeah, I can make it so the common denominator is at 12, right? So I get 2 pi over 12 minus, and if I get a 6 here and a 6 there, I would get 6 pi over 12. Unfortunately, I think this doesn't give us the same thing. It gives us, what, negative 4 pi over 12, which isn't the same thing as just positive 1 pi over 12. So for these questions, you got to make sure to find the combination that matches the inside here at the beginning of the question. So if I asked negative 4 pi over 12, this would be a way to get there. But since I only asked for pi, just 1 pi over 12, the simplest way to get there would be pi over 3 minus pi over 4. So the pi over 2 and pi over 6, yeah, would be useful depending on what's being asked. But for this one, I would just do pi over 3 minus pi over 4. Yeah, no problem. Yeah, if anyone else has any questions, please feel free to ask. If you want to, you can also scan the QR code to submit a question if you, if it's hard to type it. But yeah, hope you guys are ready for the test tomorrow. Haven't even written it yet. I still need to do that. How about 7 pi over 8, the half angle formula? Oh, tangent 7 pi over 8. Yeah, sure. So for that one, oops, wrong thing again. Okay, that one was tangent of 7 pi over 8, right? And it was in the half angles, yeah. So here's the idea of that. So it was saying we have tangent of 7 pi over 8. So if you see that, you hopefully notice that that is not in the unit circle. Let me write that 8 a little bigger. You hopefully notice that 7 pi over 8 is nowhere in the unit circle, right? If I put this back here, 7 pi over 8, I don't see it anywhere on my unit circle. That's sort of a sign that we have to use an identity. To make this work, I told you it's a half angle, but basically the idea is we want to convert 7 pi over 8 into something, I'm going to call it u divided by 2. I want to change 7 pi over 8 into something over 2. The main reason is the way we would solve for u is to multiply 2 to the other side. If I multiply 2 here, they reduce. Right? If I multiply 2 to that side, the 2's go away. If I multiply 2 to this side, the 2 and the 8 will reduce. The 2 and the 8 would reduce, and I would be left with a 4 in the bottom. And so my u in this case would equal 7 pi over 4. The reason that this is so much better, the reason why I want to use a half angle formula for this, is if I look back at my unit circle, 7 pi over 4 is on the unit circle, right? 7 pi over 4 is down there in quadrant 4. That's going to be super useful for this question now. 7 pi over 8 was nowhere to be found. 7 pi over 4 is. And so that's why I want to use it. So if we're doing tangent, I can think of this as tangent of u over 2. 7 pi over 4. I can write that all bigger. 7 pi over 4 over 2. A very badly written 2. I could think of my tangent as 7 pi over 8 or 7 pi over 4 over 2. The reason I want to do that is I have an identity for tangent of u over 2. Tangent of u over 2. There were a couple of them. I'm going to pick probably a nicer looking one because it's a tangent question. And by pick a nicer one, I mean I'm going to Google what it is because I'm kind of tired right now. Half angle identity for tangent is sine over 1 plus cosine. That's what it was, yeah. Okay, so I know if I have tangent of u over 2, that equals sine of theta, or sine of u, over 1 plus cosine u. That's my tangent half angle identity. So in this case, my u is 7 pi over 4. So this here will just equal sine of 7 pi over 4 divided by 1 plus cosine of 7 pi over 4. Aaliyah, sure, after this one. Can you do the problem in the homework where it says find sine and tan if cosine? Yes. Sine of 7 pi over 4 is from the unit circle. It's asking what's the y value at 7 pi over 4. I think that's negative root 2 over 2 divided by 1 plus cosine of 7 pi over 4 is positive root 2 over 2. And this is a totally acceptable way to leave your answer. This is absolutely fine. But yeah, the reason that the half angle is really nice is by using half angle, I could turn this 8 into a 4, and then 7 pi over 4 is on the unit circle. Sine of pi over 12 cosine. For that question, I'm not quite sure you're going to break apart those radians. For that one, I would recommend looking at the identity for sine of alpha plus beta. You should be able to just add the two together and then reduce. Let's take a look at the one Aaliyah said. Can you do the problem in the homework where it says find sine and tangent? So it's asking us to find sine theta equals something. So it says sine of theta equals, I don't know, and tangent of theta equals, I don't know. And all we know is that cosine theta equals 0.8. And we know tangent of theta is less than 0. I'm going to worry about this tangent theta less than 0 stuff later. For now, I'm going to just try and get sine, because the idea is if I can get sine, and I already know cosine, getting tangent is really easy. So I'd say the hardest part of this problem is this, getting sine theta. Thankfully, we have one really nice equation for this. We have sine squared theta plus cosine squared theta is equal to 1. This is from our Pythagorean identity, right? That's literally the exact one we use, like the one I said was the most important. Since I have sine squared theta plus cosine squared theta equals 1, my idea is, could I take this 0.8, my cosine theta, and just plug it in there? Could I just plug it in for cosine? And if we do that, we get sine squared theta plus 0.8, because that's cosine, 0.8, and we're squaring it, and we're saying that this thing is still equal to 1. All I did was replace my cosine with 0.8. So I get sine squared theta plus 0.8 squared is 0.64 equals 1. And I'm hoping that makes sense. 0.8 squared is 0.64. You can plug it into a calculator, or you can think of it as 8 times 8 is 64. So I'm going to minus 0.64 to the other side of the equation. And if we do 1 minus 0.64, because those are like terms, we end up getting sine squared theta is equal to 0.36. If you do 1 minus 0.64, you get 0.36. Last but not least, I don't really want sine squared theta. I want sine theta, and to do that, I'm just going to take a square root of both sides. Right? When I take a square root here, the square root and the square go away, and I'm left with sine theta. It might be hard to square root with a decimal there, but just think of it as a number. The square root of 36 is 6, so the square root of 0.36 is 0.6. Oops, I didn't mean to leave that much room. So I have sine theta equals 0.6. And now the part that I said we'd come back to, it's this tangent part. We're saying tangent is less than 0. So one thing that's important for this question is we kind of need to know what quadrant we're in. So since cosine of theta is equal to 0.8, I know cosine is an x value, right? And let's say 0.8 is somewhere over here. That means I have to either be in quadrant 1 or in quadrant 4. There is no way I can have an x value of 0.8 if I'm not in one of those two quadrants. Since tangent is less than 0, that tells me I have to be in quadrant 4. Because tangent is the y value over the x, right? Tangent is y over x. And if we're saying tangent is negative, aka less than 0 means negative. If the tangent is negative, that means I have to be down here in quadrant 4. If this said tangent theta was greater than 0, I'd be here in quadrant 1. All of that speaking for just saying, since I'm in quadrant 4, my y values, my sine, has to be negative. Sine of theta has to equal negative 0.6 in this case, not positive, because we're down here in quadrant 4. I know that was a bit of like a long-winded way to say that. And then, thankfully, last but not least, we're also looking for tangent theta. I know tangent theta equals sine theta over cosine theta. That's from the fundamental identities. Well, I know sine of theta is negative 0.6, right? I just got that from there. So could I go ahead and plug the negative 0.6 into sine theta? And I also know cosine theta is 0.8. I'm thinking, can I just go ahead? Oops. We're going to pretend I drew a better line than that. Can I just go ahead and plug this in for cosine? And I end up with negative 0.6 divided by 0.8. And honestly, for this class, I'm cool with leaving that as an answer. So I get tangent theta equals this, and sine theta equals that. Those are my two answers. And sorry for the really sloppy writing. It is a bit harder to write on this than I thought it'd be. So those are the two answers. Sine theta equals negative 0.6. Tangent theta equals negative 0.6 divided by 0.8. You could simplify. You could turn this into, I believe, negative 3/4 if you actually do the work for it. But if you left it like that, that's fine. I hope that makes sense. And Liliana, yeah, no problem. Let me just circle back to yours, where it was sine of pi over 12 cosine 5 pi over 12 plus, where was it? We have, what was it? Sine pi over 12 times cosine 5 pi over 12 plus cosine pi over 12. Very badly written pi. Interesting. Cosine pi over 12 times sine 5 pi over 12. I'm hoping you noticed that this was really similar to the formula for sine of alpha plus beta. Because remember, for this formula, it goes sine alpha cosine beta plus cosine alpha sine beta. So the idea I'm kind of trying to get across is, could I think of my pi over 12 as my alpha and my 5 pi over 12 as my beta? And so that means I can combine all of this stuff into just the equation sine of pi over 12 plus, very badly written, plus 5 pi over 12. Awesome. Yeah, and then combine them, you get 6 pi over 12. So I get sine of 6 pi over 12. And what's really nice about this is the 6 and the 12 can reduce. So I get sine of just, I believe, pi over 2, because 6 can go into 12 two times. And then sine of pi over 2, that's just asking the y value at pi over 2, which I believe is just 1. But yeah, if anyone has any more questions or anything, feel free to ask. But I'm hoping this helps. I know so many of the problems, they seem complicated. I'll be honest, they just look complicated. I think that's what it is. You see like pi's over 12s, you see stuff that's not on the unit circle, and you think it's way worse than it is. It doesn't help the formulas are kind of ugly, but besides that, it's not that bad. It's just hard to find the first step. Could I do the sine of theta equals 1/3 theta in quadrant 2 and find the sine of theta plus pi over 6? Sure. That one is a little bit of a tricky question. So yeah, we have, what was it? So the idea was they told you sine of theta equals 1/3. I could write that bigger. Sine of theta equals 1/3. And I'm telling you theta is in quadrant 2 for this problem. So in this problem, I'm telling you we are in quadrant 2. It almost looks like ounces. That's funny. And the question's asking kind of a weird question. The question's asking us to find sine of theta plus pi over 6. So the Greek letter theta plus pi over 6. So I'm hoping we're recognizing again that this is like that alpha plus beta idea, right? It's sine of an angle plus another angle, which if we follow the identity for that, it goes sine alpha, so sine theta, times cosine beta, so cosine pi over 6. Sine keeps the sign, so it becomes a plus, and then it goes cosine alpha, so cosine theta, times sine pi over 6. So that's the rough idea of the question. It's saying sine of theta plus pi over 6. I could think of it as sine theta cosine pi over 6 plus cosine theta sine pi over 6. Here's the hard part of the question. Sine of theta, I know what that is, right? We said sine of theta equals 1/3 right at the start of the question. So I'm thinking, can I take this 1/3 here and just plug it in? And I absolutely could. So it gives me 1/3 times cosine pi over 6. That's just a unit circle question, right? If I think about it, pi over 6 is on my unit circle. Pi over 6 is right here in quadrant 1. So if I'm asking cosine of pi over 6, I think I would just get root 3 over 2, right? The x value at pi over 6. So it's going to turn into root 3 over 2. Plus, I'm going to leave the cosine theta alone for a moment. I'm going to circle back to that one in a second. Times sine of pi over 6. Again, that's a unit circle thing. We just go to the unit circle, pi over 6, and we want the y value, which is 1/2. And you might have noticed by now, what in the world is this? What is cosine theta? To find cosine theta, that's where we're going to have to use this quadrant 2 stuff. So the idea is we're still going to use that formula from the Pythagorean theorem. Sine squared theta plus cosine squared theta is equal to 1, right? That's our Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. For this problem, I know sine of theta is 1/3. So I'm thinking, could I plug that in there as well? And the answer is absolutely yes. So I end up with 1/3 squared plus cosine squared theta equals 1. And if I'm going too fast or if you have questions, please type it in there. Let me know. I know I'm going pretty quick on this. It's hard to tell because, no one's here to give me a weird look if I'm doing something wrong on this question. 1/3 squared, that means the same thing as 1/3 times 1/3. So I'm thinking that 1 times 1 is 1, and 3 times 3 is 9. I'm thinking 1/3 squared is going to give us 1/9. Then I have plus cosine squared theta is still equal to 1. And since I'm trying to look for cosine, because cosine's over here on the left, I'm going to subtract the 1/9 to the other side of the equation. So I'm left with cosine squared theta equals 1 minus 1/9, or another way to think of that is 9 over 9 minus 1 over 9, or cosine squared theta equals 8 over 9. I'm hoping that makes sense. For the 1, you could think of it as 9 over 9, and then 9 minus 1 is 8. Oops. Lastly, I don't want cosine squared, I just want cosine, so I'm going to take a square root of both sides, and I end up with cosine theta equals, and this is going to be a little weird, I'm going to do the denominator first. The square root of 9 is just 3. The square root of 8 you can work out to be like somewhat of an okay number. For the purposes of this class, I'm just going to leave it as a square root of 8 if that's okay. The thing we need to be careful of is this a positive answer or a negative answer? And we get that information all the way from here at the very beginning with the thing we didn't use. We're saying it's in quadrant 2. So if I imagine my coordinate grid, if I'm over here in quadrant 2 somewhere, my x value would be negative and my y value would be positive. If I'm using cosine, cosine's the x, so this has to be a negative answer here. Cosine theta has to be a negative root 8 over 3. And now finally, I can do 1/3 times root 3 over 2 to give me root 3 over 6. I'm hoping that's okay. 1 times root 3 is root 3. 3 times 2 is 6. Plus, and now I know cosine is negative root 8 over 3 times 1/2. And now I can multiply the 3 and the 2 together to make a 6. And so I get root 3 over 6 plus negative root 8 over 6. You could leave that as your final answer, or you can combine this as root 3 minus root 8 all over 6. So I would take either this answer here or this answer here. Either way would be fine. It's a lot of work for one question, I know. Yeah, if you have any other questions, please feel free to ask. And if you need more of an explanation, please let me know. Thank you. Could I also do something similar to the cosine theta equals 1/4? Wait, what? Cosine theta equals 1/4 in quadrant 4. JJ, how about I do Aaliyah's first? That one's a quicker one, and then we can circle back to that one, okay? So Aaliyah, yours was sine theta equals 0.65. Find cosine of pi over 2 minus theta. So this one here is actually a very simple question. It's not going to be on the summative, nothing like it. But in this question, it said sine of theta equals 0.65. And then it asked for the really horrible equation of cosine of pi over 2 minus theta. Actually, I can make it sort of similar. If I remember correctly, this is from the beginning of the homework, but I'm going to show you how you could do this without that, though. Could I think of this as a cosine of alpha minus beta, a cosine of something minus something? You might feel weird that the theta is like second, but that's fine. So I have cosine alpha, so cosine pi over 2 times cosine theta plus sine pi over 2 times sine of theta. All I did was think of it as a cosine of alpha minus beta. Well, for this problem, we can see that we have pi over 2's for both of these, right? Sine pi over 2, cosine pi over 2. It'd be helpful if we knew where pi over 2 was. So I'm thinking on my unit circle, pi over 2. Wow, that's a really bad circle. If I have my perfectly drawn circle, I think pi over 2 is right here at the top of the circle at the point 0, 1. So cosine pi over 2, this thing just becomes 0. It's 0 times cosine theta. I have no idea what cosine theta is, and I kind of don't care. Plus sine of pi over 2. Sine of pi over 2, the y value of pi over 2 is 1. So I have plus 1 times sine theta. Zero times cosine theta is just 0, right? 0 times anything is 0. And 1 times sine theta is just sine theta. But wait a minute. Sine theta, we said that that's equal to 0.65. So I'm thinking, can we just take this 0.65 and just plug it in down here? My final answer is just 0.65. Cosine of pi minus 2 over theta is just equal to 0.65. They are the same. They equal the same thing. Which feels weird to say that. I hope that made sense. There is an identity as well that I'm not testing. It's called the cofunction identity. If you use cofunction identity, you can literally just go from here to here in like one step. JJ, let's try the other one. So what was that? Add new layer. And so you said, what was it again? Cosine theta equals 1/4. Is it really 1/4? Cosine of theta equals 1/4. And I'm telling you that we are in quadrant 4. So as I'm making this question, I need to keep in mind that we are in quadrant 4. The question's asking us to find cosine of theta plus pi over 3. So the question's asking us to find cosine of theta plus pi over 3, I think was the question. So I'm hoping that we're starting to recognize that this is that cosine of alpha plus beta, similar to the one we just did. So it's going to go cosine alpha, cosine beta. So it's going to go cosine of alpha. So my alpha was just the theta times cosine beta. So cosine pi over 3. Here's the thing with the cosine identity. When it goes cosine alpha plus cosine beta, cosine of alpha plus beta, it goes cosine alpha, cosine beta minus sine alpha, sine beta. So it can be sine of theta times sine of pi over 3. So this is very similar to the ones we've been doing. You might have noticed already, I have cosine theta equals 1/4. I could take that 1/4 and just replace it for cosine theta down here. I could just take that 1/4 and replace cosine theta. So this whole term here just turns into a 1/4 or 1/4 times, I have cosine of pi over 3. I need to know the x value at pi over 3. So I'm going to go to my unit circle. At pi over 3, I have an x value of 1/2. So I'm going to replace cosine pi over 3 with 1/2. That's going to be times 1/2. Minus sine of theta. I'm going to leave that alone for a moment. I have no idea right now what to do with that. Times sine of pi over 3. I need the y value at pi over 3. Sorry. Oh, oops. Let's get rid of that layer. There we go. The y value at pi over 3 is root 3 over 2. So I'm going to replace sine of pi over 3 with just square root 3 over 2. So this sine of pi over 3 became root 3 over 2. this cosine pi over 3 became 1/2, and this cosine theta became 1/4. The only problem with this question left is this sine of theta. I don't know what sine of theta is yet. To find sine of theta, I'm going to go ahead and go back to our Pythagorean identity. Remember we had that identity that said sine squared theta plus cosine squared theta equals 1. I know cosine of theta is 1/4, so I could plug that in. I could take this 1/4 here and plug it right into the cosine. And so I end up with sine squared theta plus, and make sure to use a parenthesis for this, 1/4 squared, because the square doesn't just go away, equals 1. 1/4 squared, that means 1/4 times 1/4. So I get sine squared theta plus 1/4 times 1/4 is 1/16. I'm hoping we're okay with that. And that's equal to 1. If I want to start solving for sine squared, I'm going to subtract the 1/16 to the other side of the equation. I'm going to subtract the 1/16 on both sides. These ones here go away, and I'm left with sine squared theta equals 1 minus 1/16, or another way to think of that is 16/16 minus 1/16, because our 1 we could think of as 16/16, which, oops, I should have the theta there, whoops. So I have sine squared theta is equal to 15/16, and then last but not least, to get rid of the square, I'm going to take a square root. So I get sine theta equals, and I'm going to do this in steps here, I'm going to take the square root of 15/16. The square root of 16 is just 4, so that's going to be sine theta equals, my denominator is going to be 4. My numerator, I'm just going to leave it as the square root of 15. I'm not going to try and do anything super creative with it. I'm just going to leave it as square root 15. The other thing we need to keep in mind is we are in quadrant 4 for this problem, right? If we think about where quadrant 4 is in terms of our xy axis, quadrant 4 is down here somewhere. Down in quadrant 4, the x values are positive and the y values are negative. So if I'm doing sine of something in quadrant 4, sine is the y value. And so my y value must be negative. So this answer here must be a negative root 15/4. But what this means is I can take this negative root 15/4, I could take this value and plug it in right here for sine of theta. I can just go ahead and plug it straight into there, because I know sine of theta equals negative root 15/4. So I have 1/4 times 1/2 is 1/8, because 4 times 2 is 8. I have a minus sign, and then this turns into negative root 15/4. And I'm multiplying that by the square root of 3/2. If I multiply root 15 and root 3, that just makes square root of 45. 15 times 3 is 45, and then you put the root on the outside. So I get 1/8. I have minus a negative here. I'm hoping we're okay with me turning that into a plus, because we have minus a negative. Root 15 times root 3 is root 45. That actually can simplify a little bit if you want to. It's not required, but it can simplify. That could simplify to 3 root 15. No, 3 root 5. 3 root 5. And then 4 times 2 is 8. If you left it here, that would be fine. Or if you simplified one step further, since they already have common denominators, you could write it as 1 plus the square root of 45/8. Either way would be totally acceptable. But this would be the answer to this question here. Cosine of theta plus pi over 3 would be equal to 1 plus the square root of 45/8. That's the answer to the question. Sorry, I know that was a really long-winded one. I hope it seems similar to the last one. Will something like this be on the test? Something this complicated won't be on the test. I'll say that. Um, would I put a question on the test where you have to get, like, if I give you cosine, you have to go get sine? Probably not. Would I give you a question where I tell you what both cosine and sine are equal to? Possibly. So if I were to give you this same question, but at the very start I told you what sine of theta was equal to, I think that would be a fair game question. Like if I were to give you what this is, if I told you this was negative root 15 over 4 at the very start, then I think that's a fair question to ask you. I wouldn't give you one where you have to find sine and then plug it all in. For the half angle formula question on the test, will you give it in degrees or radians? Okay, that is a trick. That is something I'm not sure of yet. For the half angle question, here's what it would look like. It would either be, it's one of two options. It could either be in degrees. Wait a minute, no, half angle. Sorry, I was thinking double. I was thinking difference. Half angle, I will give that in degrees. Yeah, so for half angle, I promise you I will give that in degrees. I think radians is a little mean for that. So you would have an angle like, I don't know, let's say sine of, I'd write a question like something like this, sine of, 22.5. And basically the idea is you would have to convert these degrees into a half angle. You'd have to realize that this could be written as sine of 45 over 2. Because 45 divided by 2 is 22.5. So this would be definitely a fair question for the test. I could give you something like this for sure. Where I say, hey, what's sine of 22.5? And then you have to convert 22.5 to 45 over 2. Yeah, the radians definitely do look intimidating. What I am promising is if it was a difference. So, for example, we did a question earlier where it was I think it said something along the lines of like I think it was sine or cosine, I can't remember, of pi over 12. If I were to give you this question on the test, I would have like a note here on the side and I would tell you, hey, pi over 3 minus pi over 4 equals pi over 12. I would tell you this ahead of time for sum and difference. If it was in degrees, so let's say I give you a question that said, let's use sine again. If I did sine of 15, 15 degrees, I'm not going to give you this note. I'm hoping you can figure out that you could do many different options, but one of the obvious ones would be, for example, like 60 minus 45, right? 60 degrees minus 45 degrees is 15, and then you do sum and difference with these two with alpha and beta. So if it was in radians, I would give you a heads up and tell you, hey, you might want to use these. In degrees, I'm not going to give that to you. I probably got time for like one or two more questions. I'm going to try and get out of here by like 6. But hopefully we're feeling a little better for the test. We if you came in late, if you check the VOD, we've done, believe it or not, we've done 1, 2, 3, 4, 5, 6, 7, 8 homework questions. how do you do sine of pi plus theta equals sine theta? I'm guessing that's a proof, right? Yeah, so that was a proof question. So in this one, it said sine of pi plus theta equals, was it sine theta or negative? I think it's negative sine theta, right? There's a small negative sign there, right? I think it's, I want to say it's negative sine theta off memory. So for this problem, again, we're kind of looking at that sum and difference identity again. That's sine of alpha plus beta. And if it's not negative, then tell me. I'll change it to a positive here in a second. So for this proof, I would absolutely use the left-hand side. The left side looks way worse than the right. So this here turns into sine alpha cosine beta. So it's sine of pi times cosine of theta. For sine, the sine stays the same. And then it goes cosine of pi times sine of theta. This, I think, is a really good question. Would I give you, like, I'm not putting a proof on the test, but this idea I would put on the test. The idea of this question, I think, is really good. So I don't know what cosine theta or sine theta is for this question, but I actually don't really care. They didn't give me any information about it, like, oh, it's in this quadrant, or it's in this quad. They didn't tell me anything like that. So I'm not really going to try and do much with it. What I am going to try and do a lot with is I have sine of pi and cosine of pi. So I'm going to go to my unit circle. I'm going to go to my unit circle, and looking here at pi, that's the point -1, 0. So when I'm asking us to find sine of pi, the y value there was 0. So this whole thing here just turns into 0 times cosine theta plus, and then I'm going to go to cosine pi, so that's the x value at pi. So the x value here at pi is -1. So I'm going to replace cosine pi with a -1. So this becomes a -1 times sine of theta. And I'm still trying to prove that this is equal to negative sine theta. Well, this here, 0 times cosine theta. 0 times anything is just 0. I don't have to worry about this. 0 times cosine is just 0. And then -1 times sine theta is just negative sine theta. So I end up with negative sine theta equals negative sine theta. Which, that's the entire proof. The big trick to this one is that the sine of pi is a 0, and so this entire cosine term just goes away. Sine of theta equals 3 over 3. Are you sure it's 3 over 3? Sine of theta equals 3 over 3. And what? Okay. What? Let me pull up that question. I'm not quite sure I'm understanding it from your typing. Okay, 3 over 5. That makes more sense. I was like, that 3 over 3 doesn't make much sense for that question. Yeah, no problem. I hope you feel more ready for the test tomorrow. And again, if it doesn't go your way, it's not the end of the world. There is retakes and everything, right? And if we're finding these helpful, I will definitely do these before tests, and who knows, maybe more often too. So yeah, that was saying sine of theta. This is probably going to be the last question for the day, unless anyone has any more burning questions about math. So we have sine of theta equals 3 over 5. And it says that 0 is less than theta which is less than pi over 2. And I think we're missing something from the question. What is it asking for? What are the instructions for the question asking for? Let me check here. Classwork, Unit 2 homework. Don't quite remember what this question's asking for. Okay, if you read the stuff above it, it says to find sine of 2 theta, cosine 2 theta, sine of theta over 2, and cosine theta over 2. So with that information, we want to find the following. We want to find sine of 2 theta. We want to find cosine 2 theta. We want to find sine of theta divided by 2. And we want to find cosine of theta divided by 2. So that's what the question's asking for. It's asking us, given this information, find these 4 things. So what I would do to start this question sounds kind of crazy. We know sine of theta equals 3/5, and we know we're in quadrant 1. I'm actually going to go back to drawing a right triangle. I'm going to go back to drawing a right triangle with my angle theta inside of here. And since sine is 3/5, sine is opposite over hypotenuse. So I know this side's 3, this side's 5. If I do Pythagorean theorem, I should get this side here as 4. Because 3 squared plus 4 squared equals 5 squared. So this one might take a little room, but so for the first one, it's asking sine of 2 theta. Sine of 2 theta equals 2 times sine theta times cosine theta. That's the identity for sine of 2 theta. I know sine of theta is 3/5, so I can just plug that in. Looking at this triangle here, I think it's fair to say that cosine of theta would just be 4 over 5, because cosine is adjacent over hypotenuse. So I can take this 4/5 and plug it in right here. So this becomes 2 times 3 over 5 times 4 over 5. Two times 3 is 6, times 4 is 6, 12, 18, 24. Over 5 times 5 is 25. So the answer to sine of 2 theta is just 24 over 25. That's only 1/4 of the question. Would I give you a question this long on the test? No. Do I think you should be able to answer any of these? Yes, I do think any of these could show up on the test. I don't think all 4 of them would. Next one was cosine of 2 theta. Cosine 2 theta, the identity for that is just cosine squared theta minus sine squared theta. I'm hoping it makes more sense. Yeah, it's not hard, it's just different. So yeah, I'm doing cosine squared, so I'm going to replace cosine with 4/5, so it's going to be 4 over 5 squared. Minus sine squared, sine was 3/5, so it's going to be 3 over 5 squared. And we're going to go ahead and square those two. So 4/5 squared is 16 over 25. Minus 3 over 5 squared is 9 over 25. And then 16 minus 9, I believe, is 7. So this will give us 7 over 25. So for cosine 2 theta, I'm getting an answer of 7 divided by 25. Sine 2 theta, I'm getting 24 over 25. So that would be these two done. We still need to do sine of theta over 2 and cosine theta over 2. To do those, I'm going to make a new page because I'm out of room. But I am going to copy my triangle over. So we had our perfectly drawn right triangle. This one looks worse. but that's 3, that's 5, that's 4. There's theta. And if I remember correctly, we said sine theta equals 3 over 5. And we did the work to get cosine theta equals 4 over 5. And we're specifically between theta is between 0 degrees and 0 radians and pi over 2 radians. Another way to think of pi over 2, by the way, is 90 degrees. So we're basically saying that we're in the first quadrant. We're in between 0 and 90 degrees. So almost done. Last but not least, second to last but not least, we have sine of theta over 2. For this, we have an identity. It's the square root. There's a plus or minus that goes in front of this thing. Plus or minus the square root of 1 minus cosine theta over 2. Well, in this case here, I'm going to bring down the plus or minus. I haven't thought about that yet. The square root of, I know cosine theta, that's just 4/5. So I'm thinking I could just go ahead and replace that whole cosine theta with 4/5. And I get 1 minus 4/5 over 2. And honestly, if you left it there, I'd be cool with it. Wait a minute, sorry. I'd almost be cool with it. This plus or minus I'm going to have a problem with. But something that's actually kind of nice, there's no radical inside of there. Like, it's not a radical where the cosine was. I can actually simplify that. 1 minus 4/5 is 1/5. Yeah, I'm not going to do that. No. I'll just stop there. But one thing I need to think about is it a positive answer or is it a negative answer? I need to think about, do I keep the plus or do I keep the minus? To answer that question, I'm going to look up here in terms of where we are. We said theta is somewhere between 0 and pi over 2. So if we're thinking of our unit circle, we're somewhere here in quadrant 1. My angle theta is somewhere in there. If I were to divide that angle by 2, I would still be in quadrant 1. Which means in quadrant 1, my y values are positive, right? In quadrant 1, it's a positive x and a positive y. So that means I don't want this negative answer. I want to get rid of it. I only want the positive answer. My final answer for this would be a positive square root of 1 minus 4/5 over 2. Oops. It's 4/5 over 2. And then last but not least, we need to do cosine of theta. Again, you could simplify that inside a little more if you wanted to. You could turn it into a 1/5 over 2 and then do keep, change, flip. But for cosine of theta over 2, the identity is almost identical. It's plus or minus the square root of 1 plus cosine theta. I can write that bigger. The square root of 1 plus cosine theta over 2. It's almost the exact same as the last one. The only difference is instead of a minus, it's a plus. My cosine theta is still 4/5. I'm going to go ahead and plug 4/5 right into here. So I get plus or minus the square root of 1 plus 4/5 over 2. And again, I have to have that same thought. Okay, is the x value positive or negative? Hey, look, it's positive. I want to get rid of the negative. So I know that's a longer question, but those 4 answers are what it's looking for. It's looking for sine of 2 theta, cosine 2 theta, and sine of theta over 2 and cosine of theta over 2. Would I ask you a question that has all 4 of them in one? No. Would I ask you a question to find one of those? For sure. Like, easily, yes. Yeah, no problem. I think I'm going to call it here for today. I wish you all the best of luck on the test. I will be at school tomorrow, probably around like 6:30, 6:45. So if you need help, feel free to come on by. But besides that, best of luck. Yeah. Try not to do too much work, you know. And try and go and take a nap and get some sleep tonight. Don't do all of your homework at the last minute. Yeah, no problem. Well, have a good night. Bye.